Hello and welcome to another episode of the Fully Charged podcast. One of the things that we talk about a great deal on this show is the concept of the circular economy, the notion that we must learn to reuse the materials we extract from the planet and reuse them again and again. And there's some new technologies in this area that are really, really exciting, and that's what we're talking about today. I'm joined on the podcast today by Dr. Megan OConnor, who is an American, the co-founder and CEO of Nth Cycle. Google it because you'll be blown away. They're a metal processing company, and they've developed a technology that can enable clean, domestic, and streamlined supply of critical materials for the clean energy transition. Now, that is the wording from their website, but when you hear what Megan has to say, it is amazing. And it's just I couldn't get my brains around it. I was locked in the old economy, the old system of centralized recycling. I spent a lot of time on scrapyards in my life. I know what they're like, and I know how much material we just throw away and how we could use that material again, and the enormous savings we could have on what we have to ship around the planet. So this is a really exciting episode. Really hope you enjoy it. It's a little bit shorter than usual simply because we had a bit of a technical issue in the middle. Not my fault, not Megan's fault, just life. Just doing a podcast between Brisbane and Boston in the United States. A little bit difficult to do, but we managed it. She was fantastic. She coped with technical difficulties like a true professional. Really impressive, amazing woman, really worth listening to. Really hope you enjoy this episode. So please welcome to the Fully Charged podcast, Dr. Megan OConnor. Megan, this is a real privilege for me, because what you're doing, what I always wanted to do with this show was meet people like you and interview people like you who are actually doing stuff, because it's quite easy. I've learned over my many years, it's quite easy to talk about things, ideas and new technologies. Now, I'm not saying that has no value, but it's much harder and much more important to actually do it. So I have stood on stage in front of people and said, it's really important that we recycle batteries. But I haven't actually recycled any batteries. So I wanted to, but can we just quickly go back over some of how you got to where you are? Because one of the things that really caught my attention was that you were at Oak Ridge National Labs, which I've heard of most of my life. I have no idea what it is. I've just looked it up before I spoke to you. And you were there, and it just sounds like the coolest thing. If you were doing a sort of Indiana Jones movie but about renewable energy, you would definitely spend time at Oak Ridge National Labs. It just sounds very cool and special.
I'm going to describe it like that from now on, by the way.
Thank you.
But yes, I can absolutely go through sort of the history of Nth Cycle. It all started back in 2009 when my co-founder Chad Vasitas developed really the core technology of what we're using today at Nth Cycle. And he was developing it for a completely different application in wastewater treatment. Right. And I came along in 2014 when I was a graduate student at Duke University, and just saw Chad give a talk on it. And I thought, wow, this is a really interesting piece of technology, and then sort of left it at that. A couple months later, I was able to sit in with a bunch of industry leaders in consumer electronics, and they all were talking about issues that they saw coming with recycling and then supply chain. And how do we, build enough supply here so that we don't have the issues around national security or price spikes or, anything dealing with supply chain at the time and in the future, but also be more responsible about how we deal with these end of life things, right? And these are folks in consumer electronics who make cell phones or laptops. So you're talking small e-waste. And they said, imagine when an electric vehicle comes off the road, that's just a much larger form of electronics waste. And what are we going to do with all that, right? In, 5, 10, 20 years. So that really sparked my interest in trying to figure out how do we solve this issue. And I thought back to my co-inventor's technology and said, wow, I wonder if we could use this for that application. So fast forward 3 years, we worked on this technology together. It worked better than we ever thought. And that's when I was defending my PhD and said, okay, I think we can take this out and commercialize it. But where do you take a technology when it's still so small, right? It fit in the palm of my hand. And how do you get it to
Right.
scale, right? Where do you get that capital from? And so that's
Yeah.
actually when we ended up at Oak Ridge National Labs. So the Department of Energy has a great program there called Innovation Crossroads. And it's really I call it like a landing pad for really early stage technology that is around the energy space, and it gives
Right.
it room and money to grow and for the team to come together so that you can go out and scale it as quickly as possible after that. And so we spent 2 years
Right.
there, and it was free access to lab, wonderful support there, right? Super smart humans everywhere you look. So
Right.
you couldn't be in a better place to build out a technology to where it is today. So that was from 2018 to 2020. We were there. That was
Right.
fabulous.
Wow, that is so exciting. And what a genius bit of institution. I mean, what an amazing idea that, I mean, I'm sure is replicated elsewhere around the world, but it just makes so much sense because that step from you, the two of you going, look, here's the math and here's the drawing and here's the idea.
Yeah.
Now, can you give it? Do you know anyone that can give us $100 million? Well, my aunt is quite rich. It's such a big step from that to where you are now that you've got. Yes, that it just sort of facilitates that, doesn't it? Which is extraordinary. But then, so a lot of people that watch this show and listen to this show are aware of. We talk to people, who talk about battery recycling, materials recycling, and the circular economy, and donut economics, and all that stuff. And I've even spoken to minerals extraction people, mine operators, about how essentially unsustainable the amount of materials we dig up, but also keeping it in balance because there's a huge waves of misinformation about all the lithium we've got to dig up. And there's a fabulous, I'm going to put it, actually use it in this, a fabulous illustration of, just in terms of quantity, how much iron ore we dig up in comparison with how much lithium. And you can't really see it unless you zoom right in. Lithium is tiny, and iron ore is the size of a very large opera house. It's just the scale of it is enormous, which I'm
Massive.
you're aware of that, but it is the kind of overall change that I feel is really important to take advantage of the technologies that have developed in the last 20 years, that we might be able to reuse them. It's a lot easier to recycle a battery than a gallon of diesel. I don't know if you're developing fossil fuel recycling systems, but I've been waiting for that.
Not yet.
That's going to take some time. But that it's got to be a critically important part of the discussion is how we, the word sustainable means that it lasts longer. I think a vegetable garden is fairly sustainable, goes through lots of processes. Whereas burning a fuel is not sustainable, and that's the bottom line, isn't it? But what is interesting is there's already people recycling batteries, commercially already, but they're using a different system. So it'd be great if we could just go through what the difference is because the oyster sounds like such a cool idea. I love it. But and I've worked out now the two terms, hydrometallurgy and pyrometallurgy, are the systems that are currently used to extract materials from a battery. Can you kind of go through the basics of what that involves?
Absolutely. So if you look at metal refining, right? So we think about our oyster as a new way to refine these metals chemically back to the original compounds so they can go right back into manufacturing. So if we look at the way that's been done for, over 100 years, right? That was always done in the mining space. And they've used these pyrometallurgical and hydrometallurgical processes. And these facilities are, massive, right? They are set down next to a mine. They're, billions of dollars, but it makes sense because these mines can be up to, 75 to 100 years of life, right? Operational life. And so it made sense to invest in that type of asset. Where here in the Western world, where we have a very distributed source of materials, whether you're looking at the mining world and the short life mines that we have here in the States in particular, and the distributed nature of all waste, right? Like think about where your battery goes from your cell phone, or where do you put an EV, right? It's all over the place. And so at our inception, we thought, why are we continuing to push this, old, outdated, centralized refining model into a world that has very distributed resources. Like you said, we have to figure out a way to start reusing all of this material because we simply don't have enough, or we don't want to mine more material if we don't have to, right? And that's really the source of our name, Nth Cycle, is how do we figure out a way to reuse these materials an unlimited or nth times, right? And so that was the whole idea behind Nth Cycle, is how do we develop a more modular, flexible refining capacity that can go into these much more distributed sources of material and pull them out in meaningful volumes to be able to support this clean energy transition in a much more sustainable way. And so our oyster is using electro-extraction technology essentially. And so we're using electricity and water at its core. And what we're doing, you can think of it at a high level like a Brita water filter. So in the Brita filter that you might have at home to filter out any heavy metals in your drinking water, right? It's using a high surface area filter and collects all the metals in that one stage. We've taken that same basic idea of filtering, water with metal in it, but we figured out a way to electrify that high surface area filter so that it pulls out one metal over the others, right? So it's very selective.
Right.
And we have multiple of these in series, each with a different electrical current across. And so you can imagine in our system, we can pull out copper from the cobalt, from the rare earths, from all the different, valuable materials that are in something like a battery or any other type of heavy industrial waste. And that's really, the novelty of it, is that we can do that at a very small scale to go into these regional facilities instead of having to build one centralized facility and have to essentially truck it all, right? So we're essentially reducing the transportation cost and the environmental footprint all in one.
Right. So the oyster system, when you there's the big tank at one end, but I'm assuming what you're putting in that is not like, you don't just sort of rip a battery out of a laptop and throw it in. Do you have to break them down before it gets to that process, or how does that? Because I mean, we've witnessed that firsthand. Is a machine that basically chomps up a battery pack, which is very violent, heavy industrial piece of equipment. But
Absolutely.
You've done that before you get to the stage where you put stuff in. Is that correct?
Yeah, we actually work with partners who do that. So we don't,
Right.
we're not on the collection or logistical side. We work with folks that have maybe shredded this material and have shredded it for multiple years.
Right.
And we are really just the chemical processing partner. So can go right on site with these folks and just provide them that upgrading service almost.
Right. And I mean, that has got to be a massive advantage then from the point of view of installation. If it literally uses, you need water and electricity, which are in the developed world fairly ubiquitous. Have you got a tap? Have you got a plug?
Yeah.
Right. So that's exactly. So you don't need vast amounts of energy to heat. So there's not a lot of heat involved in that, because presumably I'm guessing pyrometallurgy means there's some heat around.
That's right. So to go back to the pyrometallurgy, think of like a big furnace. It's all smelting. Right. And then hydrometallurgy is using lots and lots of chemicals, solvents. So heavy chemical burden on those. And so that adds to like the there's lots of CapEx, but then the OpEx is very high. So yes, it's very low energy. There's no heat in our system, and very low chemical usage as well.
Right. And then at the end of that, you're managing to separate all those elements out of the kind of mush you receive. And they are, because that's another thing I've heard, and I'm sure you'll be able to correct me on that. But the actual quality of those materials is not necessarily diminished by the fact that they've been used as in a battery before. When you extract them, are they as useful as they were when they were first extracted out of the ground and refined?
Absolutely. There's no, if you take it all the way back down to the purest chemical form, there's no degradation. So you can reuse it and have the same performance as you once did.
Right. And as far as we understand it, that could be done multiple times then. I mean, there's not really, I mean, have experiments we've done to see if there are limits to that, or there are no limits?
There are no limits, essentially. That's right.
Wow. I mean, I'm assuming you're going to have some losses in the bulk amount of, if you put 1 ton in and use it 1,000 times, you've got less than a ton at the end of it.
That's right.
That's over. Yeah. But then, so in terms of cost, though, is there a benefit in cost terms with the system you're installing with the Oyster system? I mean, presumably it's going to be cheaper to install just because it's not as huge. But in
That's
terms
right.
of running costs.
Yeah. So in terms of running costs, we're at cost parity with the large centralized facilities, and that's really how we're able to be modular, right? So we can go into these smaller regional facilities, and we actually cover the upfront capex because we own and operate our systems. So it's actually a pure tolling model. So our customers don't have to invest anything up front. They just pay a fee, say per pound of material that we process for them. So it's a very light lift on their part, which is great.
Right. That's a very interesting aspect of it then, because that would be. But okay, can you give me an example of what sort of company would want to install that? Then I'm not quite sure, because I'm still locked into the old model. I now realise, that it's got to be a huge facility with trains coming in, bringing in millions of tons of batteries. So it's a totally different model. I can't quite get my old head around it. So what sort of company would want to install it?
Yeah, for example, here in the US, there's over 6,500 companies that are considered scrap recyclers, quote unquote. And they have been collecting batteries, lead acid mostly, right? And lithium ion is a newer stream for them. They get autos from auction. So they're typically like traditional auto shredders who are now getting EVs in and don't know how to process them. They could get catalysts from oil and gas industry, right? That's heavy cobalt and nickel. So it's all this like heavy metal industrial scrap that would be collected, shredded, or mixed in some fashion and sent overseas to a smelter to be processed, right? That's the model of which we operate today, right? The e-waste collectors and recyclers are legally allowed to collect, mix, shred, and then send overseas. And so now that the material is so valuable and we're trying to pull our supply chains back, right? A lot of these companies want to figure out how to produce the end product out of those, very similar to how the ferrous world works, right? So the ferrous world is basically the non-ferrous world is turning into what ferrous is already doing. But they don't have either the capex or the know-how or really the desire to invest in that side of it. And so that's really where we can come in and help them and be their processing partner of say, look, like we have this technology, we can do this for you. It won't disrupt your existing operations. It's simply an add-on to be able to provide them, this really valuable and say nickel or cobalt or whatever product they want us to pull out at the end.
Right. And they can do it on site. I mean, they'll have
on site.
I have this peculiar advantage of having worked on an enormous American scrapyard for a TV series I did many years ago called Junkyard Wars. And so I've experienced the volume, the scale, the enormity. And this is a Californian scrapyard. It was just when you were in it, you could not see the far side. That's
the mountains of scrap, right? It's like it's hard for people to visualize that unless you've been to a scrapyard.
Yeah.
Overwhelming.
The other thing I learned, which is slightly off topic, but is when you're in the Californian sun and you come from a Northern European cold, damp climate, and you're walking along in between a load of cars and you stop and talk and lean on a car with a bare hand, that's a bad idea, because that piece of metal is very, very hot.
Very hot, yes.
Anyway, that's good. I've just got to jump back a bit because this is one of the advantages of being slightly thick is that you discussed ferrous and non-ferrous. And I just want to make sure that our audience understand the difference. There's going to be a lot of them who do, but I'm just asking for you to explain that in terms of recycling.
Absolutely. So ferrous is think anything with iron in it. And so for many, many decades, right, we've recycled many ferrous things and we produce end products out of those. And so that's essentially what we're trying to help the non-ferrous world do is take everything non-ferrous scrap instead of just collecting and shredding here and sending overseas to be refined into products. Right. We're trying to pull that end refining step back to the Western world with our Oyster unit.
Right, because what I think this is one of the key things that I've been sort of learning in the last few years is that you'll solve one specific problem, which is how do we recycle electronic waste? But in doing so, what you're actually doing is changing part of the global economy, which would be filling a ship with electronic waste from the United States or Europe and taking it right around the world, i.e. burning huge amounts of bunker fuel to transport it, to put it in a factory, all that stuff. And you can do that, when you see those changes, the knock-on benefits are enormous. and in my experience, they're generally massive benefits rather than extra costs in the way we've,
exactly.
I mean, that was the other thing I was going to ask is that obviously the electric car batteries are the biggest sort of lump of electronics that we're currently producing, but also the static batteries that I've been hearing about recently are vast. And I think no one really knows. Yeah, no one really knows yet quite how long those will last. But the one of the discussions I had yesterday, and I'd be interested to know your thoughts on this, is that there comes a point where it is actually more economically sensible to recycle a used car battery than to repackage it into a static storage. Because that's a story I've heard, and I know Renault have done this in Paris. There's an apartment building which essentially runs on solar panels and old Renault Zoe batteries in the basement, and they haven't they've literally repackaged them, which to an outsider makes immense sense. You just think, well, that's clever, and they'll last for another 10 years. But then there is an argument, obviously, which I think you would know about, that it might be advantageous to actually recycle them immediately. They're no use for a car, even though they're still functioning batteries. I don't know. Has that been a point of discussion that you've been aware of?
Absolutely, right. As an end of life scrap, refiner, working with the recycling worlds, right? We have to wait for all of those materials to come out of consumers' hands. And so if there's second life applications, right, we have to take that into consideration of, when are we expecting, X, volume over the next 10 years. So I think from our perspective, it's been really interesting to watch that secondary market evolve, because many folks are still worried about the safety issues, right? Around, once these batteries come out of, say, an EV, are they safe enough to use in, a stationary application, or is it the right chemistry, right? These batteries in cars are going to, hopefully be on the road for 10 plus years. And at that stage, are we going to be past the chemistry that was put in there? And I think that's when the economics are in favor of going directly to recycling, is because they might have used, just for an example, a 111 chemistry where, they have a lower nickel content, and now people are pushing for a higher nickel content. So it's like, where in that life cycle are we going to have these batteries coming off the road? And is it going to be the appropriate sort of chemistry for the battery that the stationary application is going to want? I think it'll be a continuing dynamic, and it'll be very interesting to watch that market evolve. But those are sort of the two pushbacks I've heard of recycling, as soon as it comes off the road, because, there's such a high value for these materials to go into brand new types of batteries for all applications.
Right. No, that is a very interesting point. Yeah, another thing you mentioned in passing, because it's such a contentious issue and has been for the last few years, is cobalt. So that just to clarify, you can extract cobalt from the mush that comes out of a load of mashed up batteries. That is possible.
We can, yes. We can collect all the different metals.
Right. So, because that's. But one of the other ones you mentioned was that heavy industrial waste, which I assume which you can also recycle. One of the things I just can't believe I didn't work out early on is that I spent 2 days filming at a big oil refinery in the UK. There's only 3 really big ones, and this is one of them, an enormous facility. And I remember them describing how they used cobalt in the oil refining process to remove sulfur particularly from diesel fuel. And I don't know what happens to that cobalt, or whether it gets kind of washed away, or they could recycle. So, is that a product that you could possibly recycle?
Absolutely. And those are the types of sort of heavy industrial waste that we're targeting, because our technology allows us to do that, right? It's such a different way of doing the same processing that you'd see in the large hydro or pyrometallurgical processes. But a lot of times it wasn't economical to ship those waste to those centralized facilities, or they weren't built out to be able to accommodate the varying, deleterious materials that are in that stream. So that's exactly what we're trying to do, is pull out all the metal from all of these different waste types that we have, and batteries is really just one of those.
Right. It's really good to hear that, because that's, it's just one of those things where cobalt was effectively used as a weapon by the fossil fuel lobby to say all electric cars are evil because children have to dig up the materials for your holier than thou liberal. I can't remember the list. It gets more offensive. I've been called all of them. And then you go, and of course I was at a conference with someone from Amnesty International who originally did the report about artisanal mining in the Congo and the kids, and it's terrible. But then you realize where that cobalt goes is a lot of things other than car batteries.
That's right.
We are all culpable, essentially, is the argument. And so in a sense, then this is a small modular approach to what has been a massive heavy industrial problem. I mean, do you see that in 10 years' time anywhere where like the scrap yards I've experienced, the junk yards full of cars, there will actually be one of your systems in the corner of one of those facilities, just busily getting on with recycling everything. Wow, that is it. It is, isn't it?
Absolutely. Yeah. And we've, the mission and the vision of the company is really to redefine what metal refining looks like across the supply chain. So we're starting in the recycling industry just because there's, like you said, such a great case for reusing all the materials that we've already dug up out of the ground. But then unfortunately, we're going to have to continue to mine these materials no matter, how much we recycle. And so we are also working with clients on the mining side as well, rethinking like, what does mining refining look like, right? It's the same technology that we can pivot across the supply chain. And that's really an additional benefit that we can bring, especially to countries where mining is not thought of, in a positive way, right? But we have to continue to do this if we want to move forward in the energy transition. So let's figure out a way to do it more sustainably.
Right. So let me get my head around that, because I'm in a country where mining is very, very central to their economy, if nothing else, on a vast scale. But I mean, could you, for instance, at an iron ore mine, could you produce the iron from the iron ore, at the mine site?
Essentially, yes. For nickel mines or for cobalt, copper, right? We have those types of assets here. So we don't typically work in the ferrous or iron world, but yes, that's the goal, is to be able to go to any of these critical mineral sites that we have here that might not be economical, or smelting can't fit within the environmental permitting or regulations for each different state. But our technology could help, bring those assets into the supply chain, essentially.
Right. And I mean, also, if you're in a remote area where, for instance, a nickel mine or a cobalt mine, or in Australia's case, I mean, there's a lot of lithium extraction in 60% of global lithium comes from Australia, which nobody seems to know. That's like more than half. I'm not good at math, but 60% is more than half. I can work that out. But you could have that's one of the things that is happening here, is that the mining industry is realizing that they can produce their own fuel on site for their vehicles, because they've got it. So they are converting. Currently, there's a company here converting 8,500 electric pickup trucks for the mining industry, not one or two special ones. 8,500. So really big scale stuff, and they're big mining trucks. But also, if your system uses water and electricity, they can produce their own electricity. I think a mining company is going to go, I think we could save them. So, I mean, that is it really, I can understand how that would make sense. Just quickly, can it scale up? I mean, could you scale, because the system you've used would you just have more of those modules, or could you actually produce it bigger? More modules. Okay.
More modules. That's right. That's the beauty of the system. Yes.
Right. It's kind of I'm going to use this term, and it's very British, but it's annoyingly clever.
I love that.
Well, only because, no one else, I mean, I don't know if anyone else has thought of it, but it does. I've not come across anything like this before. And I've sort of looked at this world in some detail over the last 10 years.
Yes, annoyingly clever. I love that. It's something that seems so obvious, and when you look at the supply chain, we tried to just take, a realistic, holistic approach of what does this industry really need. It doesn't need us to be, shoving an old centralized model into, again, these very distributed resources. So we wanted to take more of a scalpel approach of like, how do we really try and solve the pain points that we have, especially here in the Western world, where, we don't have these massive mines. We don't have sort of the support that we would need to put in these massive facilities, and we have very distributed waste. So how do we go about this and really try to solve this issue from the sort of ground up?
Yeah, no, I mean it is it's really impressive, and I wish you well with it, because I think I'm just hoping. I mean, I guess the last question, because I haven't looked into that as a proper journalist, would have done much more research than I have. But I'm assuming you've got funding and backing and support to expand. And I mean, are you confident that you can roll out this technology at scale?
We are. So we've been, very fortunate with the investors and the community around us that's been supportive in our commercialization pathway so far, and we're, actively looking for partners and funding, over the next several years to get to the scale that we know that we can to make the biggest impact possible.
Right. That is fantastic, Megan. I want to thank you for talking to us today, because it's such an exciting and critically important thing. Because I mean, it's often we look at where the general public can ignore waste, and we have done for generations. And I think we're just beginning to get to a state where you go, we can't really throw all this stuff away anymore. We actually have to think about it and do something about it. So what you're doing is, I think, is really, really exciting, and I wish you well with the future of it. And I'm looking forward to one day visiting a junkyard and seeing one of your systems in operation.
Yes, that would be lovely. I would love that. So thank you so much. This has been great.
I really hope you enjoyed that. I'm going to be begging Megan to attend the Fully Charged live show in San Diego later this year, or in Vancouver, whichever she can do. I don't know if she can. I've not heard back. I'm just hoping she can, because she is an extraordinary person doing really critically important things. Anyway, that's all we've got time for this episode. Please do tell your friends about the Fully Charged podcast. Please do subscribe if you haven't done already. Our subscriptions are going up. It's wonderful. But that's basically the top and bottom of it. So, as always, if you have been, thank you for listening.